our next speaker is Mike Hart. He is the president and CEO of Sierra Energy, a company that is taking its unique technology, converting any form of waste to clean energy, and providing it to communities around the globe. This is a company committed to reducing greenhouse gas emissions around the world, and with its success, Mr. Hart has been deemed a champion of change by the Obama administration and an environmental hero by the EPA. Please join me in welcoming Mr. Mike Hart for a presentation titled Waste to Energy, Landfill to Grid.
Thank you all very much. I appreciate that kind introduction. First off, I'd like to thank Chip and Sally for the introduction to come here. This is my first visit, and certainly my first visit to Snowmass. If I had known, I would have brought a bottle of oxygen for my hikes. High up here. In any case, what I'd like to talk about today is a significant source of greenhouse gas and a potential solution. For your reference, the average American throws away the equivalent of 14.5 school buses worth of garbage over the course of their lifetime. In the public's perception, there are only 4 things that we can do with waste. We can recycle it, some of it. We can compost a portion of it. Some people burn some of it through incineration, and landfilling is the most common solution. But landfills aren't a sustainable solution. There are about 2,100 permitted landfills left in the United States right now. They charge an average of about $45 a ton to take that garbage and throw it away. But it pollutes the soil, it can contaminate the water, and it also can potentially cause a significant amount of greenhouse gas when it's released into the atmosphere. 1 ton of waste creates 3.5 tons of CO2 equivalent in the form of methane that's being released into the atmosphere. To give you some idea, as far as the inventory of greenhouse gases going into the atmosphere right now, about 76% is carbon dioxide and about 16% is methane. But methane is 80, and by the way, a real shout out to Hank the other day. Hank Rogers on the thing of, why is it called natural gas? Anyways, methane is 84 times more potent a short-term climate change agent. And so it's one that we really need to pay attention to. To give you some sort of metric as far as the amount of waste that's being thrown away globally right now, we throw away about 1.3 billion tons of garbage every year as a planet. That's a line of garbage trucks stretching from San Francisco to New York City every single day being thrown away. That's estimated to rise to 2.2 billion tons in the relative near term by 2025, according to the World Bank. That means that right now we're generating about 4.5 billion tons of CO2 equivalent going into the atmosphere from those landfills, and that's rising to 7.7 billion tons. I think we all share a goal of zero waste, either through having the producers come up with products that don't require a lot of packaging, finding ways to divert different parts of the waste stream to other useful products and such. But that's the goal we all share. But we're not there yet, and we're a very, very long way from making that happen. Right now, there are a number of conversion technologies that are available. There's a whole bunch of them. In fact, you guys went through a historic event today at 11 a.m. and you didn't even know it. A whole new technology of getting rid of waste was created this morning at 11 o'clock. They loaded up the Cygnus spaceship with 2 tons of waste and they pushed it in the atmosphere and it was disintegrated overhead at 11 o'clock this morning. But in any case, so this is, there's a whole bunch of different technologies. I'm going to focus on gasification. That is a different category of ways to take waste and turn it to something more valuable. There's a whole bunch of different types, and I'm going to focus specifically on fast ox gasification, which is a technology my company has developed with the US Army and the California Energy Commission. Where we think gasification fits in the grand scheme of things is behind recycling. Obviously, first you reduce. When you reach the point of being able to recycle whatever makes sense in your community. That varies wildly. I've been all over the world talking about this in different countries and in different communities. and what they recycle varies wildly. It depends a lot on economics, but generally about half the waste stream can be economically recycled. You then find that anaerobic digestion can take about 30% of a waste stream, and that's usually the organic segment. A lot of cities are now actually separating that out, and when that's possible, anaerobic digestion can make economic sense. What you're left with after that is about 20% of the waste stream nobody knows what to do with. That's the real mess. That's where gasification steps in. Gasification can take complex waste and recycle it. So our technology came from the steel industry. It's basically a blast furnace, but what we've done is down at the bottom where they blasted in air, we've converted the nozzles into these computer-controlled nozzles that precisely inject oxygen and steam. So what that means is that in one unit, we can take any form of waste, break it down molecularly at 4,000 degrees Fahrenheit, which means there can be metal, there can be glass, there can be all kinds of other things that are mixed into the waste that stop other processes. We make a medium density synthesis gas, or syngas, and the emissions, if you're making electricity with it, are actually significantly lower than if you were using methane or natural gas to run a power plant. When you factor in the amount of greenhouse gases you're offsetting, you actually have a negative carbon footprint when you make energy from this source. The economics are competitive, and what's important about that is that means that people in the landfill industry can do something that's more profitable than what they're doing today. President of one of the biggest waste companies in America told me, no amount of government regulation is going to change their industry. However, show him a path to something that's profitable and the industry will change overnight. That's what we're doing. The way the process works, you throw the waste in the top, you inject the oxygen down at the bottom, it works on gravity. It's very simple, there's no moving parts. What you end up with is as the waste descends, it heats up to 4,000 degrees Fahrenheit, it breaks down. Everything that's solid melts. You end up with liquid metal, so you can recycle all of the metal that's in the waste stream. Any inorganic solid is recycled as a slag, a liquid slag. It actually pours out like lava. So you're able to recover everything. You're then either able to turn that into road base, or you can actually use it as a cement replacement. If it's ground granulated blast furnace slag. So that means everything is recycled in the process. The gas that comes out is a mix of 70% carbon monoxide and 30% hydrogen. What you can do is you can then turn that into a variety of things. You can make ethanol, you can make diesel that's 20 times cleaner than the California fuel standard. You can make renewable hydrogen, which currently there is no good way of doing. You can make fertilizer, or you can just make electricity. The feedstocks that can go into this system vary wildly. We can use municipal solid waste, biomass if it's available, medical waste, hazardous waste. We've used tires, railroad ties, construction demolition debris, hazardous waste nobody else knows what to do with. At 4,000 degrees, it all breaks down. So you run through this process and you're able to create this synthesis gas that can then turn into these valuable products. Key topic. Gasification and incineration are completely different things. They have nothing to do with each other. Incineration takes air, which is 80% nitrogen, so it creates a huge volume of waste gas. They then have to clean that up before they discharge it in the atmosphere. In the case of gasification, the gas is the product. Because you're injecting a small amount of oxygen, the gas coming out is extraordinarily clean and is the product that then can be used to make other final products. It also creates more than double the electricity. In China, where we've been talking to people, they love incinerators. They have them all over the place. The problem is they create dioxins and they create toxic ash that then has to be landfilled. But for them, the most important issue is it doesn't make a lot of money. If they switch to this approach, they make a lot more money, and that's the key. You double the energy efficiency if you're making electricity. The other technologies, I'm not going to go in a lot in the detail, but other different gasification technologies have limitations as far as what they do. Fast ox gasification overcomes those by creating an inert stone product. There's very low parasitic load for making it, and there's very little pre-processing required to run it through the system. One of the important metrics is when you're making a megawatt of electricity. If you're using solar, you consume about 8 acres. Wind, about 6. Coal, smaller, nuclear, natural gas. And finally, we use about 1/4 of an acre of land to actually create a megawatt of electricity using fast ox gasification. In California, where we come from, water's a big deal. And when you're looking at other ways of making energy, they consume an enormous amount of water. In our case, we're net water positive because waste has a significant amount of water in the stream. So that means we actually create about 40 gallons of water for every megawatt of electricity we create. We've run our commercial prototype. We developed it with the Army and tested and proved the system. We're building our first commercial facility on an Army base in Monterey County, California right now. We're expecting to be commissioned in September of this year. And so this is a very exciting step for us. We've been working on this for 12 years. So we're finally at the stage now where this technology will be made available. Anybody who's interested in seeing how their county would do as far as using this technology, go onto our website on the SierraEnergy.com. There's a calculator. In 1 minute, you can create a complete business model showing the amount of greenhouse gas that can be reduced and what kind of profitability there is. Because in the end, folks, unless something's profitable, people aren't going to change overnight. What we're looking for is to take our technology and spread it globally. And what we're doing is we're doing online licensing to put this in the hands of local developers around the world through our website. The idea is that one company might build 3 systems in 10 years. I want to see 50,000 of these put around the world over the course of the next decade. We believe that we can reduce overall global greenhouse gas using this technology between 10 and 20% globally. It's going to break a lot of business models. It's going to annoy the hell out of a lot of industries doing what we're doing. The waste industry hates us. There's a lot of people that are very annoyed with what we're trying to do because it destabilizes what's going on. But if I can paraphrase in a room like this, Barry Goldwater, I would like to say that extremism in combating climate change is no vice, and moderation in that pursuit is no virtue. I believe it's appropriate to do whatever we can do. And if we can find a way to use a technology like this to make the planet a better place, we should do it. Thank you all very much. I believe I have 3 minutes for questions if there are any. Sir?
What are you using fuel?
There is no fuel in our system. What we do is we use the carbon that's in the waste itself that was already being thrown away. We don't need any external power source. Yeah, that's it. Yes, sir.
Have you done any kind of analysis? I know you have the calculator, but have you done any kind of analysis? And I know you have the calculator, but what would you say is the minimum population in a given area to generate an adequate feedstock
Yes.
for this technology?
10,000 people in the United States. A community of about 10,000 would be ideal. That's the 20-ton per day Pathfinder, which we've just released, and we're already taking orders for getting this thing out there right now. But it obviously, it becomes much more economic with scale. The bigger it gets, the better it is. In China, they're talking like 1 million people. Yes, sir?
Yeah, you were talking about applying this to 20% of the waste stream. Why don't you apply it to more? You're talking about applying it to 20% of the waste stream and doing other things with the rest of it. Why not apply it to more of the waste stream?
Sure. And in fact, that's an excellent question. The Army wanted us to come up with a system that could be used internationally in conflict zones where they would actually do 100% of the waste stream. Right now, they do this horrific thing called burn pits, which create huge toxic plumes where they pour diesel on top of garbage and they burn it. It causes horrific problems for the soldiers and it leaves a toxic nightmare. The military is looking at this to consume 100% of the waste stream. They're really not in a position of recycling overseas. We can take the entire waste stream, but I believe in communities where it's possible, where they are able to segregate recycled materials, for example, aluminum, certain plastics, paper, where they can take that out, or the organic material, they should. What's left, we'll take. We're sort of the goalie. Whatever's left over, we'll deal with. Yes, sir?
A few years back, I worked with a doctor named Alan Hershkowitz,
Okay.
researching this stuff, and we compared the American process to that in Germany and Japan. And we had a real problem with plastics, which you addressed, but
Yeah.
I'm still trying to figure out exactly how you get that out of the waste stream and the dioxin.
Sure. First question, as far as plastics. Plastics are just basically long chains of hydrocarbons. 4,000 degrees, they don't survive. They turn into carbon monoxide and hydrogen. And so any complex kind of plastic breaks down and is very easily used in our process. Second question is dioxin. Dioxin formation is a relatively low temperature, not high. At 4,000 degrees, we don't get dioxin formation. UC Davis has been our partner in the analysis of this. We ran our pilot facility for 5 years. and demonstrated conclusively we can take any of these waste streams. We've taken electronic waste, everything. One more, is that all right? Please.
What's your cost of hydrogen?
Okay, on hydrogen, that's an interesting question, and I didn't pay you to say that. But right now, one of the worst things you can do is run a fuel cell vehicle, because the hydrogen, it's basically made by breaking down natural gas and then releasing an enormous amount of CO2 in the process. It's not a very good technology if you can't find a good fuel source. However, there are ways of doing it solar and things like that, but you lower the cost from about $12 per kilogram of hydrogen. We can make it for 43 cents a kilogram, which is the 86 cents a kilogram, which is the equivalent of 43 cents a gallon gasoline, using renewable hydrogen using our process. I'm done. I should introduce the rest of the panel, which is now going to follow. Thank you all very much.